In Python, we're all taught that when a function hits a return statement, that's it. It's game over. But what if I told you there's a way for a function to break that fundamental rule? Today, we're diving into Python generators. They're a special kind of function that can give you a value, hit pause, and then come right back for more. And trust me, this one little trick unlocks some serious power, especially when you're working with massive amounts of data.
I mean, really think about it. A normal function runs its code, hits return, hands back a value, and then poof, its entire world, all its local variables, just vanishes. So the idea of a function that can give you a value, pause, and then pick up exactly where it left off to give you another one later, that just sounds impossible, right? How would that even work?
Now, this idea of getting values one at a time isn't totally brand new. We've had something called iterators for a long time. But here's the catch. If you wanted to build one yourself, you had to create an entire class with all these special, kind of confusing methods. It was a ton of boilerplate code just to get that simple one-at-a-time behavior. It worked, sure, but it was anything but elegant.
Thankfully, Python gave us a much simpler way to get the job done. We don't need a class, we don't need any of those special methods. All it takes is a single, magical keyword that completely changes the game for how a function behaves. And it all comes down to this one simple comparison: return versus yield. At a glance, return 5 and yield 5 look almost the same, but under the hood, they are from different planets. Return gives you the value and slams the door shut on the function forever. But when you swap that word for yield, well, that's when you turn a regular function into something else entirely.
And that something else is what we call a generator. The second that the Python interpreter sees the yield keyword inside a function, it stops thinking of it as a normal function. Instead, it becomes a generator factory. When you call it, it doesn't even run the code. It just hands you back this special generator object, all ready and waiting to produce values whenever you ask for them.
Honestly, this is the absolute best way to think about it. Our return statement is a hard stop button. The function ends, its memory is wiped clean, it's done. But yield is a pause button. The function hands you a value, then freezes right in its tracks, remembering everything, every variable, its exact location, just waiting for you to hit play again.
So if calling a generator doesn't actually run it, how do we get the good stuff out? Since it's this pausable factory for values, we need a way to say, okay, I'm ready, give me the next one.
And there are basically two main ways to do this. You can use the built-in next function, which is like manually cranking the handle once to get the next value. It gives you a lot of control. But way more often, you're going to use the easiest and most Pythonic way, a simple for loop. A for loop just inherently knows how to talk to a generator, automatically asking for the next value over and over until there are none left.
So let's picture a simple generator that has 4 lines: yield 1, yield 2, yield 3, and yield 4. When we wrap a for loop around it, the loop just takes care of everything. It automatically asks for the first value, gets 1, asks for the second, gets 2, then 3, and finally 4. We get all the values one by one without any fuss.
Okay, so that's the basic mechanic. But now for the real magic. The feature that makes generators so incredibly powerful. They remember things. They have a memory, a state. To really see this in action, let's build something a little more interesting. A generator that calculates the first 10 perfect squares. All right, let's look at the code for this function. We'll call it top 10 squares. It starts with a counter, n, set to 1. Then we have a while loop that's set to run 10 times. Inside, we calculate the square of n, we yield it, and then, and this part is absolutely crucial for its memory, we add 1 to n before the function pauses. Okay, let's trace this step by step. Imagine we start a for loop with this generator. The first thing the loop does is knock on the generator's door and say, "Hey, can I get your first value, please?" The generator springs to life. N is 1. Inside the loop, it calculates 1 times 1, and then it hits that yield 1 line. At that exact moment, it hands the value 1 over to the loop, and then it just pauses. It freezes in place, but not before remembering that it just updated n to be 2. So the for loop takes the 1, does its thing, and then comes back around for another go. It asks for the next value. Now the key is the generator doesn't start over from the beginning. It wakes up right where it was snoozing, right after that yield statement. So the generator resumes. It already knows that n is 2. It goes to the top of the loop, calculates 2 times 2, yields the value 4, updates n to 3, and hits pause again, waiting patiently for the next call.
And this beautiful little dance just keeps going. The for loop keeps asking, and the generator keeps waking up, doing just enough work to figure out the next value, and then going right back to sleep. This happens over and over until n hits 11, the while condition is finally false, and the function gracefully exits.
So this is all very clever, right? It's a neat programming trick. But what's the actual benefit? Why wouldn't we just build a list of 10 squares and return it all at once?
The answer, and this is the whole point, has everything to do with memory. For 10 numbers, it really doesn't matter. But what if we were dealing with 10 million numbers? Or reading a file that's billions of lines long?
Just imagine you're processing 1,000 records from a database. A normal function would try to fetch all 1,000 records, load them into a gigantic list in your computer's memory, and only then return it. But a generator? It would fetch just one record, yield it to you, and wait. You process that one record, and only then does it go back to get the next one. This isn't just a small optimization. For big data sets, it's the difference between your program running beautifully or crashing because it ran out of memory.
And this is exactly why generators are so fundamental to writing efficient Python code. They are the perfect go-to tool for working with huge log files, for processing live data coming in from a network stream, or really for handling any sequence of data that's just too big to fit into memory all at once. They let you write clean, simple code that can handle gigantic data sets like it's no big deal.
So that's the magic behind yield. It's a simple concept with some really powerful implications. Let's do a super quick recap of the main points, and then I've got a little challenge for you. All right, here's what you need to remember. First, just adding the yield keyword is what turns a regular function into a generator. Second, generators are lazy. They produce values one at a time and only when you ask. Third, their superpower is remembering their state, their memory between each call. And finally, all of this makes them incredibly light on memory, which is a total game changer for big data. And now it's your turn. Based on what we've just gone over, just think about this for a second. What would the code for a super simple generator look like if its only job was to yield the string hello and then yield the string world? Give it a shot. It's the perfect first step to really getting the hang of this awesome concept.